Alright, this video is to help you review for the honors chem test on the periodic table. Key things you need to know: you obviously need to memorize the groups of the periodic table, where they're located. You need to know periods. This is really, the focus is really on trends and ion size. That's what I'm really going to be covering in here, so I'm going to start. First trend you need to know is atomic radius. Atomic radius is basically the largest atom on the periodic table is basically francium. It's not listed here. But basically, as you go down, it gets larger, and as you go across from right to left, it gets larger. But all you really have to remember is, if you think of like an imaginary flag being stuck in francium, that means the largest radius is always the one closest to the flag. So like if you're comparing calcium and you're comparing silicon, the fact that calcium is automatically closer to the flag means it's got to be larger. So that's what you want to do with the periodic trends. Just remember which one's the biggest, and then the one that's closest to that will always be the larger value. The one that's farther would be the smaller value, and we can do increasing and decreasing. Valence electrons, remember the first group, or group 1 in the periodic table, has 1 valence electron. Group 2 has 2, and then technically it says group 13, 14, 15, 16, 17, and 18 on your periodic table, but you ignore the 1 because this tells you group 13 really has 3 valence electrons, group 14 has 4, 15 has 5, 6, 7, and then finally 8, except for helium has 2. The trend for electronegativity. So francium's here. We put a flag in it here for size or radius right there. If you come over here, fluorine is the most electronegative element there is. So I'm going to basically put En right there for electronegativity. So if I'm asked to compare phosphorus and gallium right there, phosphorus is closer to the flag than gallium is, therefore phosphorus has to have a higher electronegativity. If I'm comparing calcium and magnesium, if you look, magnesium is technically closer to the flag, therefore it is a greater electronegativity. So instead of remembering left, right, up, down, know where the flag is. Then if they ask you a question like, if you go from left to right in the periodic table, what happens to electronegativity? As you get closer to a flag, closer means it goes higher. So as you go this way, it gets closer to the flag, it means it goes higher. So that's the flag for electronegativity. The definition for electronegativity is the amount of, or how strongly an atom attracts electrons when it bonds. And we'll get more into that later on in the course. Electron affinity, how much energy is released when an atom gains an electron. Fluorine is going to be the most electronegative, or have the highest electroaffinity, or EA. It's in the game. So for example, if you're asked to compare oxygen and carbon, oxygen is going to have a greater electron affinity than carbon is, because the flag, I'm going to put my flag in fluorine. If they ask me to compare potassium and cesium, potassium is basically going to be a larger value as well. The fifth trend is ionization energy. The definition is the amount of energy required to remove an electron, the outer electron basically. The flag again for ionization energy is going to be in fluorine. Technically, noble gases like helium is the highest, but really we say they don't really ionize, so we focus more on the halogens. So here's your table. Let's say you're going to go take a test. What do you have to remember? You basically put a gigantic flag here. Remember that electronegativity, electron affinity, and ionization energy, the flag goes there. For down here with francium, really it's just size or radius, same thing. But then the last thing is metallic character. Remember, the more metallic the element, the larger it is, the easier it loses electrons. So the most metallic is also francium. So instead of remembering all 5 of these trends, what I would suggest you do is just remember radius. The flag for radius goes, hold on, let me get this page set back. The flag for The flag for radius is basically down here. Radius and metallic characters here. Any of the other trends are opposite. So then when you go to basically have to solve these, key things you need to know are basically the closer you are to the flag, the stronger it is. When they ask you increasing, means you're going from the farthest out in. They ask you decreasing, you're starting from the closest and moving your way backward. The other thing that comes up is more positive the ion. Remember, metals, which are on this side of the periodic table, form positive ions. So they're automatically going to be smaller. If you are a positive ion, you're automatically smaller. Metals lose electrons. If you are a nonmetal, if you think about it right here, nonmetals are here, you're going to gain electrons, which means you're going to be larger. Whenever you gain electrons, wow, that's not the writing I want, you're going to be larger. You're going to be a larger atom over there. So those are key things to remember. So if we look here, the more positive the ion, the smaller it is. So for example, if I am comparing sodium is Na+, Mg is Mg2+, and they ask you which one's smaller. The more positive, 2+, and 1+, magnesium automatically is going to be more positive because it's more positive because of the positive 2 there. Therefore, this is going to be a smaller one than sodium. So the first thing I look at is if they're asking me to compare ions, the more positive it is, the smaller it's going to be. The more negative a charge on an ion, the larger it's going to be. So if you were asked to compare N3-, O2-, and F- for size, the first thing I'm going to do is look for the ion charge. That has a -3 ion charge, which automatically makes that the largest. You have to just memorize, the more negative the ion, the larger it's automatically going to be. This would be the second largest, and finally that would be the smallest. The only other thing comes up is what if you have a tie, Mg2+, Ca2+. When the charges are the same, you go back to the flag rule. It's like a tie. So it's Mg2+ and Ca2+. So I go back over here. I'm going to clear my writing. Mg is here, Ca is here. The flag for size is this. So if they're asking me who's the largest, well, calcium is closer to the flag. So then when you go back to this question right here, Ca2+ would be a larger ion, okay? Because the charges are the same. There's no difference in positive value or charges. All right, so when I go to do this, they're asking me boron, aluminum, gallium, and indium. So the first thing I'm going to do is I'm going to take my magic highlighter, and I'm going to highlight the elements. So we're talking about boron, which is right there. Oops, that makes it kind of hard to see. Let's do this. I'm going to highlight boron right there. No, try it again. I'm going to use the pen. I'll use the purple pen. So boron is right there. Aluminum is right there. Gallium and indium. So there we are. There's all 4 of them. And they're going to ask me different trends. The most metallic. Well, the flag for metallic character is right there. So the most metallic is going to be indium because it's closer to the flag. So I would say most metallic is In. Least metallic, well, boron is the farthest away from the flag. So the answer to least metallic would be boron. Lowest electronegativity. Well, the flag for electronegativity is going to be in fluorine. So I put an En right there. Well, who is the farthest from the flag? That is going to be indium, so I'm going to write In. Highest electronegativity, who's closest to the flag? Boron is going to be the closest to the flag, so it has the highest electronegativity. Largest radius. Well, the flag for radius is right there. So if I look, I have indium, gallium, aluminum, and boron. Indium is closest to the flag, so that means it will be the largest radius. They asked me the smallest radius. Boron is the farthest from the flag. Boron would be the smallest. If they asked who is a nonmetal, in this case there aren't any nonmetals. Remember, nonmetals are basically carbon, this section down here. These are representing the nonmetals right there. Order from smallest to largest. Okay, so going from smallest to largest, order. Smallest means you're farthest from the radius flag. Here's my radius flag. So it's going to be boron. There'll be boron, aluminum, gallium, and then indium from smallest to largest. Okay? Let's go to the next sample. All right. Here we go. We have silicon, which is going to be right here. I have sulfur, phosphorus, and aluminum. So I have these 4 elements I'm focused on. Highest metallic character. My flag's going to be right there for metallic character. Well, who's the closest to the flag? That is going to be aluminum. Highest electron affinity. Well, the flag for electron affinity is right there, Ea. So who's closest to the flag is going to be sulfur. Lowest ionization energy. Well, remember ionization energy? The flag for ionization energy is going to be right here. And I'm looking at lowest. So when I look at these 4, who's the farthest from the flag? That would be aluminum. Highest ionization energy is going to be sulfur because it is closest to the flag. Radius. The flag for radius is right there. So If I'm looking for the smallest atomic radius, it's going to be sulfur. Metalloids. Metalloids on the periodic table, it's asking you which of these are metalloids. The only metalloid is going to be Si right there. That's the only metalloid. Easy way to tell metalloids is this. Just remember BAT, B-A-T, because if you go boron, silicon, arsenic, tellurium, acetane right there, AT, those are the 5 metalloids, and you just have to remember G and SB. Those represent the 7 metalloids. It's an easy way to remember who the metalloids are. This video is basically intended to help you review for periodic trends. Make sure you review for the history of the periodic table as well. Just check at the notes. And then know the groups of the periodic table, especially these are some groups you need to know. The first group here is the alkali metals. Second group is the alkali earth. Noble gases are here. Halogens are there. The orange colored is representing the transitional metals. And then the metalloids are, I talked about what the metalloids are. They also ask you on the test to be able to differentiate between these are all the metals. Metals make up the majority of the periodic table. These are all the non-metals. And then finally the metalloids are the ones, the region, kind of I call it the fence that separates the two of them. So definitely know the different groups of the periodic table, know where to find them, and it'll make the test a lot easier. All right, I hope this helps. I will see you tomorrow. Any questions, you can contact me at eric.divis@palm, I should write on this, Palm Beach Schools.org. Okay? You want to be asked. All right, have a good night, and I will see you tomorrow.